All right, welcome to this explainer. Today, it's all about protecting your data. We're stepping into the classroom to totally demystify one of the absolute cornerstones of object-oriented programming, or OOP. So if you've got an exam coming up, you are in exactly the right place. We're going to unpack encapsulation. You know, why should we restrict direct access to our data? What on earth do getter and setter methods actually do? Well, stick with me. We're going to answer all of those questions with some really practical visual examples so you can confidently ace your test. Okay, so let's kick things off by imagining a literally catastrophic coding failure. Think about a banking app, right? What actually happens if the data controlling a user's bank account balance is just left completely unprotected? Well, a user, or even just a simple glitch, could directly force that balance into negative $5,000? No way, right? But without any built-in rules to stop it, the system just blindly accepts the bad data. It's a software developer's absolute worst nightmare, and honestly, it happens all the time when we ignore the principles we're about to dive into today. Here's our quick roadmap for today. We're covering why data hiding matters, the core logic of encapsulation, public, private, and protected access, getter and setter methods, some critical exam questions, and finally, the golden rule. Jumping right into section 1, why data hiding matters and how to secure your data. This right here brilliantly illustrates the stark contrast between a vulnerable system and a secure one. Look at the left side. We're seeing a massive anti-pattern. The balance is directly manipulated to negative 5,000. There's zero security, no validation, just wide open doors. But then, check out the right side. We have a secure best practice system. The system actively rejects that invalid negative input, keeping the balance at a safe, logical 1,000. The difference between the left and the right? Well, that is literally the difference between a failing grade and a perfect score in software design. Okay, section 2, the core logic of encapsulation, or as I like to call it, the hidden hero of OOP. The crucial takeaway is this definition right here. Encapsulation is essentially the practice of restricting direct access to an object's internal state, its variables, and only allowing the outside world to interact with that data through specific, controlled class methods. Think of it like a protective, impenetrable force field wrapped around your class's internal data. You can't just reach in and grab what you want. You kind of have to politely ask the methods to do it for you. Now, what's really cool about this is how we can translate code into something we all use, an ATM. So you walk up to an ATM. Inside is a safe full of cash. That cash represents your private data. You are absolutely denied direct access to that safe. I mean, you can't just pry it open. Instead, you interact with the keypad and the screen, and these are your public methods. You use a public method to withdraw cash, another to deposit cash, and another to check balance. The ATM tightly controls the whole shebang, ensuring you actually have the funds before it hands over the money from the safe. That is encapsulation, perfectly modeled in the real world. All right, moving on to section 3, public, private, and protected. These are your access modifiers. Take a second to really look at this comparison. Honestly, this is a perfect screenshot moment for your study guide. These are the specific coding tools we use. Public basically means the data is accessible from anywhere. It's an open door. Protected means the data is accessible within the class itself and by any subclasses that inherit from it, kind of like a VIP room. But private. This is where encapsulation truly lives. Private data is accessible only within the class it was created in. In languages like Python, for example, we denote private variables using a double underscore before the variable name. That double underscore, that is the padlock on our ATM safe. Section 4, getter and setter methods. I like to call these guys the data bouncers. So if the data is locked away and private, how do we actually use it or change it safely? Let's see how this builds a secure environment. Step 1. When the outside world wants to see the private data, they absolutely must use a getter method. The getter simply reads the data and hands over a copy safely. Step 2. When the outside world wants to modify the data, they've got to use a setter method. But here's the catch. The setter doesn't just blindly write the new data. It validates the new input. And step 3. It only actually changes the internal private data if the new input passes the specific business rules you've coded. These methods aren't just for reading and writing, they're your frontline security guards. And listen up, because this is where a lot of students lose easy points on their exams. Look at the left side here. This is what we call a weak setter. It takes an input and just blindly assigns it to the private variable. There is zero validation. Just writing a setter without any logic inside it is a totally useless anti-pattern. It completely defeats the entire purpose of encapsulation.
Now look at the right side. This is a strong setter. Before it updates the balance, it actually checks, hey, is this new value greater than 0? If yes, it updates. If no, it rejects it outright. Always write strong setters.
All right, time to shift into high gear. Section 5, critical exam questions. Let's really test your knowledge.
Here's your first question. Read it carefully. What is the term for providing access to data exclusively through class methods? I'm going to pause for just a beat. What's your guess?
And the solution is encapsulation. If you ever see a question about hiding data, preventing direct external manipulation, and exclusively using methods to access that data, the answer is always, for sure, encapsulation. Memorize this definition. It is a guaranteed point on your test. Okay, question number 2. Let's see if you remember our anti-pattern comparison from just a minute ago. Why is it necessary to perform a check or validation inside a setter method? Think about that weak setter versus the strong setter we talked about. The solution? To prevent invalid data entry. Remember, without validation, a setter is practically useless. We use validations inside setters to stop users from entering illogical or even dangerous data, like a negative age, a negative bank balance, or a password that's way too short. Ultimate control and security, that's what we're going for here. Let's tackle one more. This is a super common scenario-based question. If a car class prevents direct access to the brand data and instead uses a car_info method to interact with it, which OOP concept is applied? Solution: encapsulation. Did you spot it? The scenario explicitly mentions preventing direct access to data and providing limited access through a specific method. Method-based access to hidden variables is the undeniable telltale fingerprint of encapsulation. Spot those clues in your exam code snippets and you'll nail it every time. Let's cement everything we've talked about today. Section 6, the golden rule, and our final takeaways. Okay, if you remember absolutely nothing else from this explainer today, remember this drop the mic quote. Expose what the object can do, not its insides. Your focus as a developer should literally always be on defining the behaviors and the methods of your class for the outside world, while keeping the actual raw data, the internal state, locked away safely. And I'll leave you with this final, kind of provocative thought. Think about your own code for a second. Looking back at the very latest programming project you wrote, which variables did you accidentally leave completely exposed to the outside world? Yeah, now that you know the true power of encapsulation, it might just be time to go back and add some serious security to your code. Good luck on your exams and happy coding.